When using a generator to temporarily backfeed a panel, safety is paramount. This information outlines the necessary steps and precautions. Firstly, read all instructions for the specific generator model before operation. Different generators have different requirements and safety features. Understanding the manual is crucial for safe and effective use. Secondly, ensure the generator is properly grounded. Grounding provides a path for stray electrical currents, protecting against electric shock and equipment damage. Refer to the generator's manual for specific grounding instructions. Thirdly, connect the generator directly to the panel using a generator cord with the appropriate gauge and length for the generator's output. Using the correct gauge wire minimizes voltage drop and prevents overheating, which can lead to fire hazards. The length of the cord should be as short as possible to further reduce voltage drop. Fourthly, turn off all breakers in the panel and remove the main breaker. This step isolates the home's electrical system from the utility grid, preventing backfeeding and potential hazards for utility workers. Fifthly, install a generator interlock kit. An interlock kit is a mechanical device that prevents the main breaker and the generator breaker from being on at the same time. This is essential to prevent the generator from backfeeding power into the utility grid, which could endanger utility workers and damage equipment. Sixthly, turn on the generator and plug it into the panel using the appropriately sized and wired inlet. Ensure the generator is running smoothly before connecting it to the panel. Seventhly, turn on the generator breaker in the panel, and then turn on the breakers for the circuits to be powered. Start with essential circuits like the furnace and a few lights to avoid overloading the generator. Eighthly, monitor the generator's fuel level and temperature, and refuel or cool it down as needed. Generators require regular maintenance and monitoring to ensure they operate safely and efficiently. Running a generator out of fuel can damage the generator. Overheating can also cause damage and create a fire hazard. Now let's discuss the don'ts of using a generator to backfeed a panel. Firstly, never use a generator indoors or in a garage. Generators produce carbon monoxide, a deadly, odorless, and colorless gas. Always operate the generator outdoors in a well-ventilated area, away from windows, doors, and vents. Secondly, never connect the generator directly to the panel without a generator interlock kit. As mentioned earlier, an interlock kit is essential to prevent backfeeding into the utility grid. Connecting a generator directly to the panel without an interlock kit is extremely dangerous and illegal. Thirdly, never overload the generator. Overloading can damage the generator and the appliances it is powering. Check the generator's wattage rating and the wattage requirements of the appliances to be powered to avoid overloading. Fourthly, never operate the generator in wet or snowy conditions. Water can conduct electricity, creating a shock hazard. Protect the generator from the elements by placing it under a canopy or using a generator cover. Fifthly, never touch the generator's terminals or wires while it is running. The terminals and wires carry electricity and can cause electric shock. Always turn off the generator and disconnect it from the panel before touching any electrical components. Sixthly, never leave the generator unattended. Generators require regular monitoring to ensure they are operating safely and efficiently. Leaving a generator unattended can lead to potential hazards. Regarding the specific scenario, a 2-pole 50-amp breaker would likely suffice for a 5,000-watt generator, as the generator's maximum output current is 46.1 amps. The calculation is as follows: 5,000 watts divided by 240 volts equals 20.83 amps per leg. However, this is a general guideline. Electrical codes require that overcurrent protection be sized to protect the wiring and the generator. Even the 5,000-watt generator is rated at 46.1 amps at 120/240 volts. This indicates a potential for up to 23.5 amps per leg at 240 volts or 41.66 amps at 120 volts. Therefore, the 50-amp breaker is within a safe range, but the specific wire size used to connect the generator to the panel must also be considered. A wire size capable of handling at least 50 amps must be used. The National Electrical Code, or neck, provides guidance on selecting the correct wire size for different ampacities. For example, NEC Table 310.16 lists the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius. For copper conductors, a 50 amp circuit typically requires a minimum of number 6 American wire gauge, or AUG, THHN wire, assuming it is rated for 75 degrees Celsius. Aluminum conductors would require a larger gauge. This is a critical safety consideration. To select an appropriate breaker size for a generator, one must understand the generator's continuous output current and the National Electrical Code requirements. The breaker must protect the generator's wiring from overload while allowing the generator to supply its rated power. Typically, the breaker is sized no greater than 125% of the generator's continuous output current. For example, if a generator has a continuous output current of 20 amps, the breaker should be no larger than 25 amps. This ensures that the breaker will trip if the generator is overloaded, preventing damage to the wiring and generator. To determine the appropriate wire gauge for a generator connection, several factors must be considered, including the generator's maximum output current, the length of the wire run, the ambient temperature, and the type of insulation on the wire. The National Electrical Code, specifically Table 310.16, provides guidance on selecting the correct wire gauge for different ampacities and conductor types. It is also essential to consider voltage drop, especially for long wire runs. A larger wire gauge may be required to minimize voltage drop and ensure that the connected equipment receives adequate voltage. Always consult the NEC and a qualified electrician to determine the appropriate wire gauge for a specific generator installation. When backfeeding a generator into a home's electrical panel, a crucial component is the interlock device. This device ensures that the main breaker and the generator breaker cannot be on simultaneously, preventing backfeeding into the utility grid. There are different types of interlock devices available, including sliding plate interlocks and breaker interlocks. A sliding plate interlock typically consists of a metal plate that slides to block either the main breaker or the generator breaker, preventing both from being on at the same time. A breaker interlock uses a mechanical linkage to prevent simultaneous operation. The selection of an interlock device depends on the specific electrical panel and the generator setup. It is essential to choose an interlock device that is compatible with the panel and meets all applicable safety standards. Installation should be performed by a qualified electrician to ensure it is done correctly and safely. Connecting a generator to a home's electrical system without an interlock device is extremely dangerous and can have serious consequences. Backfeeding into the utility grid can energize power lines that are assumed to be energized, posing a risk to utility workers. It can also damage the generator and the home's electrical system. In addition to the physical danger, backfeeding is also a violation of electrical codes and regulations. To ensure a safe and code-compliant generator installation, always use an interlock device and consult with a qualified electrician. They can assess the specific needs and recommend the appropriate interlock device and wiring configuration. Grounding a generator is a critical safety measure to prevent electric shock and equipment damage. A generator should be grounded to provide a path for fault current to flow back to the source, tripping a circuit breaker and energizing the circuit. There are two main types of grounding system grounding and equipment grounding. System grounding involves connecting the neutral conductor of the generator to the grounding electrode, which is typically a ground rod driven into the earth. This establishes a reference point for the electrical system and helps to stabilize voltage. Equipment grounding involves connecting the non-current carrying metal parts of the generator and the connected equipment to the grounding electrode. This provides a low impedance path for fault current to flow back to the source, tripping a circuit breaker and preventing electric shock. The specific grounding requirements for a generator installation depend on the size and type of generator, as well as the applicable electrical codes and regulations. In general, portable generators should be grounded by connecting a grounding electrode to the generator's grounding terminal. Permanently installed generators should be grounded in accordance with NEC, which may require the installation of a dedicated grounding electrode system. When selecting a generator for temporary backfeeding, consider the wattage requirements of the appliances and equipment that will be powered. Calculate the total wattage by adding up the wattage ratings of all the devices to be connected. Choose a generator with a wattage rating that is sufficient to handle the total load, with some extra capacity for starting surges. Starting surges occur when appliances like refrigerators and air conditioners initially start up, drawing significantly more power than their running wattage. To accommodate starting surges, the generator should have a surge capacity that is at least 2 to 3 times the running wattage of the largest appliance. It is also important to consider the voltage requirements of the connected equipment. Most household appliances operate on 120 volts alternating current, or VAC, while some larger appliances like electric stoves and dryers operate on 240 volts alternating current. Choose a generator that provides the appropriate voltage for the connected equipment. Most generators have both 120 volts alternating current and 240 volts alternating current outlets. When operating a generator during a power outage, it is important to take precautions to prevent carbon monoxide poisoning. Carbon monoxide, or CO, is a colorless, odorless gas that is produced by the incomplete combustion of fossil fuels. Generators produce carbon monoxide, so it is essential to operate them in a well-ventilated area, away from windows, doors, and vents. Never operate a generator indoors or in an enclosed space such as a garage or basement. Carbon monoxide can build up quickly and reach dangerous levels, leading to serious illness or death. Install carbon monoxide detectors in the home to provide an early warning of carbon monoxide buildup. Test the detectors regularly to ensure they are functioning properly. If carbon monoxide is suspected, evacuate the premises immediately and call emergency services. It is also crucial to consider the proper storage of fuel for the generator. Store gasoline in approved containers away from heat sources and open flames. Keep the containers in a well-ventilated area away from the house. Never store gasoline inside the house. When refueling the generator, turn it off and let it cool down completely before adding fuel. Spilled gasoline can create a fire hazard. Use a funnel to avoid spills and wipe up any spills immediately. Dispose of used gasoline properly, in accordance with local regulations. When connecting appliances to a generator, use heavy-duty extension cords that are rated for outdoor use. Check the wattage rating of the extension cords to ensure they can handle the load. Avoid using multiple extension cords connected together, as this can create a fire hazard. Keep the extension cords away from water and foot traffic. Inspect the extension cords regularly for damage, such as cuts or frayed wires. Replace any damaged extension cords immediately. Consider using a power strip with surge protection to protect sensitive electronic equipment from voltage fluctuations. Generators can sometimes produce voltage spikes that can damage electronic devices. Surge protectors can help to absorb these spikes and protect the equipment. When the power is restored, disconnect the generator from the panel and turn off the generator breaker. Then turn on the main breaker and reconnect the appliances to the grid. Allow the generator to cool down completely before storing it. Store the generator in a dry, well-ventilated area away from flammable materials. Follow the manufacturer's instructions for long-term storage. Change the oil and clean the air filter before storing the generator. This will help to prevent corrosion and ensure that the generator is ready to use when it is needed again. In summary, safely backfeeding a panel with a generator requires careful planning and execution. Firstly, always follow the manufacturer's instructions for the generator. Secondly, use an interlock device to prevent backfeeding into the utility grid. Thirdly, ground the generator properly to prevent electric shock. Fourthly, choose a generator with sufficient wattage and voltage capacity. Fifthly, operate the generator in a well-ventilated area to prevent carbon monoxide poisoning. Sixthly, store fuel safely and refuel the generator carefully. Seventhly, use heavy-duty extension cords and surge protectors. Finally, disconnect the generator when the power is restored and store it properly. Remember, electricity can be dangerous, and it is always best to consult with a qualified electrician to ensure that the generator installation is safe and code compliant. While this information is intended to be helpful, it is not a substitute for professional advice. Always prioritize safety and consult with a qualified electrician for any electrical work. Understanding electrical safety principles and adhering to best practices can help prevent accidents and ensure a safe and reliable power supply during outages. Also be aware that local codes might differ from national codes. Always consult with a professional. Remember, this information provides a general overview and does not substitute professional guidance.